Okay, good morning, everyone. Thank you for joining us for today's Journal Club. Our first speaker is Brian Herr, who is a PhD fellow at NCAS at the Faculty of Veterinary and Agricultural Sciences at the University of Melbourne. He'll be talking on the topic using natural language processing in VetCompass Australia to create tools to understand veterinary antimicrobial usage patterns. Thanks, Brian.
Thanks, Arjun. So thanks again for the intro. Today I'm talking about natural language processing in VetCompass to understand antimicrobial usage patterns. My supervisors are Laura Hardefeld, Karen Bespor, Tim Baldwin, James Gilkerson, and a committee chair is Carolyn Mansfield. So today I'm going to be largely talking about sort of what my PhD research is on, with a highlighting the first area of studies, which is focused on what antimicrobials are being given in veterinary medicine, as well as the quantities that those antimicrobials are being prescribed. So just about me a little bit to give a bit of background, because I guess I wasn't always a veterinarian. I originally started out as a systems engineer at Microsoft. I got my veterinary degree, DVM from Washington State University. It was class of 2011. Also, I wouldn't be here without my wife and daughter Maya, who were in between with me, and all this stuff. I initially went into emergency medicine, did small animal medicine, worked in zoo and exotics, was in Australia for a bit of that time, up in Cairns Turbo Rehabilitation Center, up in the upper right. I currently still do work with the RSPCA, and I worked with the Bears over in Washington State for a little bit. I also did some startups, and both in Silicon Valley as well as Sydney. And then I found myself doing a PhD here at University of Melbourne when I was looking for doing something with natural language processing, and found a joint degree program that I could do with veterinary science department as well as the computer information systems department at University of Melbourne. So a little bit about the problem. I won't go into it too much to this audience because everyone here is aware about antimicrobial resistance. And stewardship as well. I think a lot of people are focused on antimicrobial stewardship. We have one of the papers that review papers that I just like to highlight, showing that antimicrobial stewardship has been shown to be effective in hospital environments. This is a review study, looked at 20 studies to show that there's a 51% reduction in multi-drug resistant gram-negative bacteria. So that's a little bit of background. But why are we looking at veterinary medicine in particular? And this is because veterinarians are under scrutiny for contributing to multi-drug resistant pathogens, as well as they have multi-drug resistant pathogens in their clinics as well. There's also, in general, a lack of oversight in companion animal medicines, or thought to be there of. And this work isn't just started by me. Laura Hardefeld had done some initial studies with looking at veterinary students' knowledge and perceptions about antimicrobial stewardship, as well as population-wide assessment using pet insurance data in the past, and so it's building on top of that. And of course, ongoing work with NCAS and the Australian Strategic and Technical Advisory Group on antimicrobial resistance. And we're using their rating system for this study, the ASTAG system. So a little bit of background about VetCompass. It's essentially big data for veterinary medicine. It's an extremely large data set that can reveal patterns, trends, and associations of diseases and treatments in veterinary medicine or anything related inside the clinical records. And in Australia, it's currently a collection of over 181 veterinary clinics across Australia and contains over 20 million clinical records within it. So the rating system that we're using, as most people are aware, but just to go over it again, is the ASTAG rating system. So we have low importance, medium importance, and high importance antimicrobials. Low importance are basically the antimicrobials that are broad spectrum, or not broad spectrum, but they should be the first line of defense. Medium importance generally include some broad spectrums, but they should be used only if low importance are used up. High importance should be reserved only if the other ones are not being shown to be effective. So going and looking at the patterns is a big part of antimicrobial stewardship, but using a VetCompass data set sounds like a great idea, but it's not really that easy because the data is just unstructured free text mostly. It's semi-structured, it's very rich, but it's also very noisy. There's multiple consult records that just don't have prescription labels, they're blank. Inventory items have no labels or categorized as miscellaneous items. There's single accounts logged in by multiple veterinarians, so there's a lot of hurdles to overcome in veterinary medicine or inside the VetCompass dataset, which is why we're looking at using natural language processing. So natural language processing is this area of computer science and artificial intelligence, and that's concerned with the interaction between computers and human languages. So it gives us the ability to process large amounts of natural language data like free text. It also enables the task of turning this free text into labeled data and structured data that we can then report on. And so there's various approaches to natural language processing. Probably one of the ones that we hear a lot about in the news these days is deep learning neural networks, but there's also machine learning, which is also a very trendy word. But they all kind of rely on these rules-based approaches behind them, and some of them are pure rules engines, which are just standard algorithms that we've been using for years as well as currently. And to do this with VetCompass, I've essentially set up a pipeline to integrate the natural language processing into it. So we have the data from VetCompass, and we can extract those labels. We then label those records with the antimicrobials. We match the ingredients to the medications, and then we map their ASTAG ratings, and then import the label data back into VetCompass. So with searching for antimicrobials specifically, there was a number of hurdles, including there's not a dictionary of a comprehensive list of all veterinary drugs available. And so that had to be manually created with Laura Hardfeld and myself, as well as mapping the drugs to the ingredients that are inside each of the drugs that are available in veterinary medicine in Australia. And then afterwards, we had to map those ingredients to their various ASTAG ratings. And then last but not least is we had to create the algorithms for searching the drugs in VetCompass data to match them all together. And so to find out what the best way to do this was, we tested a number of rules-based methods as well as machine learning models, which include the deep learning and the neural networks. So to give a little bit of idea of how annotation of the antimicrobials went is we have these records. This is an example of a prescription label. So we see the drug name, the units dispensed, how it's being administered, and the frequency of administration, as well as the length of treatment. So we want to get enough label data to be able to train our algorithms. So we had two experts, myself and Laura Hardefeld, label 200 records to calculate our agreement score. And then we figured out our FLICE kappa score between the two. And we determined it was a 0.868, which is reasonably accurate. Essentially equates to about 95% accuracy between the two of us for doing these annotations. Once we have that, we use that as the gold standard. So I went ahead and labeled the remainder of a subset of the records. So we took all the inventory items from Victoria, which we figured would be a good representative sample and was easy to isolate because it was all the hospitals in Victoria, all their inventory items, and there's over 2,300 individual inventory items in there. So those were manually labeled. And then we tested various machine learning models. They did pretty well, but then the best one was actually a rules-based algorithm that was created. And so it was about 96% accurate, and the F1 score was 0.85, and which is very comparable to how our annotation agreement was. So you kind of have a glass ceiling with these accuracies, is that you can't really get better than the accuracy of the annotations, because a lot of times, even though you have these gold standard annotations, they were created by humans, which are prone to errors. So if you're creating algorithms and comparing them to your handcrafted ones, then or your hand labeled set, then you end up having a lot of errors that you're not going to ever be able to get 100% essentially. And so going through the records, we had to filter some of the records that we're actually reporting on. So the caveat before I show some of the data is that it is pre-published data, so it shouldn't be shared widely. And then also the records that are on here we removed records that were missing, and we focused on dogs and cats exclusively, as well as we excluded certain months with high ratio of miscellaneous medications. And we used a subset from 2013 to 2018 for the initial study. And we also, for the reported data that's here, which we've changed in the future, but we excluded mupirocin, polymyxin B, neomycin, and fusidic acid, as these were exclusively used topically in veterinary medicine. So for the preliminary analysis, we also used Tableau as a way to do the data interrogation for the data analysis part once we had all the label data. And this connects directly to SQL Server, which is quite nice. And we could either query it directly or extract the data for analysis with Tableau. So an overall overview of what we had, we have the consults per 1,000, or we were showing the data at a rate of how many antimicrobials are given per 1,000 consults. So overall, we have about 700,000 patients and about 4.4 million records. And the overall usage was about 110 antimicrobials given per 1,000 consults. It was slightly higher in dogs than it was in cats as well, which correlates well with studies that Laura did with the pet insurance data. We looked at the different areas that antimicrobials were given, and they're roughly right around 10% across all the different states in Australia. We didn't have anybody reporting in the Northern Territory or Tasmania, which is why they're not on there. And this is just, again, showing the same data I was showing before, where it's not just about looking at the antimicrobials that we're giving and the rate of antimicrobials, but also the high-rated antimicrobials. So this one looks at the high-rated antimicrobials. So even though cats get overall less antimicrobials per 1,000 consults, they get almost 4 times as many high-rated antimicrobials per consult. And this is, again, looking at the high-rated antimicrobials. And on average, it sits right about the same, right about 20 antimicrobial events per 1,000 consultations. And so this next chart is really focused on, sort of inspired by some of the research that I'd seen by Rod James, which is a way to present information about what an individual clinic is doing and what their performance is compared to what the average of the different clinics around it are. So this one shows just what the averages are and then the outliers in there. So then that way, if a clinic is an outlier, they can look at themselves and say, hey, I'm an outlier. You know, what are our projects? What are we doing to make ourselves want to be, you know, more within the standard range of everybody else? It also allows us to look at if we have an outlier, you know, maybe there's a good reason. We have these red dots here that represent the emergency and specialty hospitals, and some of them, you know, it makes sense that they give more antimicrobials, but they are distributed through the middle when we look at the high-rated antimicrobial prescriptions that they're given. Because if you are a hospital, we're not trying to make it so that less antimicrobials are given. We just want to make sure that they're being given appropriately and that hospitals are aware or clinics are aware of where they sit on these things as far as antimicrobial administration. And then looking here is a chart of the most popular antimicrobials given in veterinary medicine. And we can see that we have overall, the most popular one by far is amoxicillin clavulanic acid. And then the most popular high-rated antimicrobial is cefovecin. Other than that, enrofloxacin is also one of note, but all the other ones are less than 1% of the high-rated antimicrobials. So, which equates to less than 1,000, 1 out of 1,000. So more importantly is not just what's on this list, but probably what's not on this list. And so it's important to look at, there's no glycopeptides, there's no fourth generation cephalosporins, there's no anti-MRSA cephalosporins, there's no carbapenems, streptogrammins or monobactams, or etc. So that's really good news overall in veterinary medicine. So this initial analysis tells us a few things, right? So if we ask the question, are there #, high-rated antimicrobials being prescribed in veterinary medicine? You know, we say yes. They're mostly limited to cefovecin, enrofloxacin, and less than 1% other fluoroquinolones. And if we look at, is there a significant amount of high-rated antimicrobials being used aside from these 2 medications? And, you know, the answer is no. You know, most antimicrobials used in companion animal practice are either medium or low risk. So we don't just want to look at the amount of antimicrobials we're given, but we also want to look at the dosage that we're given. So we want to make sure that we're giving the correct dose. So there's, because some antimicrobials are time dependent, whereas others are concentration dependent, and other ones still are a mixture of both concentration and dose, or frequency of administration. So to do that, we started looking at the algorithm. We started looking at the labels and tried to break them down further. So initially, we were just looking at the antimicrobials, and I showed this chart before, which was talking about the different components of a prescription label. So we start to look at the different parts of this label. So we start to look at the total units dispensed, the route of administration, frequency of administration, length of treatment, so we can add to it. And so To do this, we performed named entity recognition for the remainder of the entities, and we broke down these named entities into numbers and integers. So this is so that we can create an equation to calculate the dosage amount, length of administration, and extract the frequency of administration. And so to do this, we use neural networks for the named entity recognition. I used a model that's referred to as NeuroNER, and as well as we use character-enhanced token embeddings, and then some additional rules-based algorithms to break down these named entities. And then afterwards, we extract additional features from VetCompass, such as the weight of the patient that's already in the records, and then we calculate the fields for dosage and length of administration. So this is just, it's not, I just wanted to go over the neural architecture really quick. But essentially, the way it works is we have a representation of the characters as well as the words that feed into it. And then once we have that, we sequence it through the neural network, and then we figure out what the most likely named entities are based on the representation of those words and the sequence that they represent, or based on the representations that the neural network gets, then it's able to figure out what the likely sequence is of those labels. So to give an example, like if we take the prescription like this, that says amoxicillin 500 milligrams, give 2 capsules morning and night until gone. The patient weight is 50 kilograms. The units dispensed are 28. We want to structure that data to create the formula, 500 times 2 divided by 50 equals 20 milligrams per kilogram. So going from words to that formula, essentially. We also want to look at the formula, 28 tablets divided by 2 divided by, or 28 tablets and then divided by the twice per day times the 2 tablets per day dose. And so that way we know that we have 7 days worth of administration that we're getting in there. So some of the very preliminary analysis is we were looking at the fluoroquinolone example because that one is the time and dose dependent. That one can be given once a day or twice a day. And so looking at the variance in dosage between twice a day or once a day. Sometimes people split the dose between giving the same amount over the course of 1 day. Otherwise, they'll give a larger amount for a single day dose. But it seems like that there is a discrepancy there, and we should look into it further just to make sure people are consistent with their fluoroquinolone doses, or maybe there's differences in outcomes depending on how they do these dosages. Other ones that we were looking at was amoxicillin clavulanic acid, just as an example. So there is most people are doing the right thing. This is one that does have to be given once every 12 hours for it to be effective. And so most people are doing the right thing, but there are occasionally outliers for this, like where they do give only once a day on a higher than average basis when they're just doing single day dosing. So that's something that should be looked into, and more appropriate measures, or they could have an antimicrobial stewardship that maybe educates more about the effectiveness of dosing just in case they need refreshers, and don't just give antibiotics because it helps them maybe feel better about the case. And so our current work is what was the presenting complaint and the diagnosis in the medical notes for each consult where an antimicrobial was prescribed. So if we take that other information, we want to know more about appropriateness of dosage. So then we need to know what is the reason that they're getting these different dosages. Because right now we have very raw data. We just have what antimicrobials are being given. We're starting to look at frequency, but we don't necessarily know why those antimicrobials are given. So this is done, we're looking at using existing methods, but essentially it revolves around using a whole bunch of labeled data. It's a lot more difficult to label clinical records with what the diagnosis was in those clinical records. So we need to go back and look at some ways to get that information. So we're experimenting with a few different ways. We're looking at different methods that were in the I2B2 task, which had a shared task focused sort of on this task and looking at some of their methods. It's a little bit dated, but there are some things that give us guidelines, as well as looking at, there was some work specifically in veterinary medicine, looking at the hierarchical relationships of diagnosis and disease groups. That was recently published, sort of looking at a way to do groupings of the disease. So that way, rather than just saying we have a very specific disease like coronavirus, instead just say that it's a gastrointestinal disease. And that makes it a lot easier to label these diagnoses. So we're currently working on getting those labels and then also manually labeling some records in VetCompass Australia to help get us to bootstrap the other labels that we'll have from other sources. Because when you use labels from a different data set, so if we use VetCompass Australia, and then we're trying to label VetCompass Australia, but we use VetCompass UK data, veterinarians in UK don't necessarily have records that are exactly the same. So then if we try to label Australia records, they won't necessarily look the same. So we'll have to make modifications to our algorithms, give it some data that's fed into it that's very specific to the way that veterinarians create records in Australia to be more effective with those algorithms. And once we finish that, our intention is to look at the relationships between not just if they have an antimicrobial and what disease they had when they got it, but then also the problems and tests associated with the antimicrobial prescription. So again, once we know what disease they have, the next step is to see like, well, was there a culture given before the antimicrobial? And because we're overall looking at, is there appropriate usage going on? And in order to do that, we still need to come up with the methods for that section, but again, it will be largely based on some previous works that are there. So just in summary, VetCompass combined with natural language processing, we feel is a valuable tool that can help us look at antimicrobial usage patterns. However, fast and accurate analysis of however, the data is very noisy and further work is required to make these things more readily queried. But it is important as fast and accurate analysis of the ongoing usage patterns essential for measuring effectiveness of the programs that we do when we do antimicrobial stewardship. So I just want to acknowledge everybody for helping me. My supervisors again, James, Laura, Karen, and Tim, as well as my advisory chair, University of Melbourne, National Council for Veterinary Antimicrobial Stewardship, as well as VetCompass Australia, and Green Cross Vets, who are a large supplier of, or a supplier of a large amount of the data that we're currently using. Sorry. Oh. So with that, I'd like to open up for any questions. Thanks. Yes, Karen.
So, given the noise of the data, one way to improve the quality is to introduce some lookups or fields or requirements to meet the description, minimum requirements for description, such as writing an indication, which is the approach we do in general practice, where we're going to have a tool that will enforce an indication for a period of time. Because that's a lot of work, and this is, if we get it in there, it's really less work, which will probably give you better quality data. What's your thoughts of that?
Brian, could you repeat the question?
So the question, the question was that there's being some tools introduced in human medicine to help label the data by enforcing the requirement to write indication of use when the label's produced or while they're creating a prescription label. And then what the thoughts are around introducing those measures in veterinary medicine or just in general?
Well, there's a lot of work to do this where standardizing the quality of data going into these prescribing software might get you to where you need to go off the cuff.
Right, so I kind of look at it more as a hybrid approach. So again, Karen was saying that this is a lot of work to do all these measures versus if we just have the disease label to begin with, it's a lot easier. And I would say, yes, it is a lot easier, but I think that the accuracy of that data, if it was enforced properly, it would be good, but then also you end up, what we don't want to do is to dissuade usage or to begin with, like if something needs an antibiotic, they should give it. And I guess my fear with that is that if we start getting in the way of between a doctor and writing the prescription or doing those things, the more steps involved with it. If it's voluntary, the less uptake you'll have. And if it's mandatory, the more pushback there's going to be to get those policies implemented. So there's the bureaucratic side of it, but then also once it's enforced, I guess I would just get worried at what level does it cost, the veterinarians, because the veterinarians are already under pressures to do really quick appointments to get these things done. But if they could write some indication, because I believe those are the guidelines for and like antimicrobial prescriptions is you're supposed to write why it's given anyways. So
it's a clinical care standard for antimicrobial stewardship. So writing indication is one of the main requirements, which is actually in human medicine supposed to be applied across all sectors, hospitals, and general practice. It's not enforced though, but they are, at least in hospital accreditation, our guidelines now actually talk about these clinical care standards. So it's probably a way ahead of where veterinarians are at the moment in terms of the countries around their accreditation.
Yeah, I think it's important, but I think the thing I worry about is like what is that field? Is it just what the body part, or is it a venom code, or is it a SNOMED code? Because a lot of times what I see in human medicine is it ends up being something, and a lot of my resources are based largely on the US standard, which is they want to make sure the provider gets paid. So they end up doing very specific ICD-9 codes, and it's very time consuming and it's very difficult. Like, so I guess that's why I look at more of a hybrid approach where I don't think it should be so restrained. I think natural language is a good way to communicate. It's because
I'm not saying don't do it. I think it's fantastic and it really should be part of our future. And the other thing to say is understanding why an antibiotic is given for anyone is cognitively very complex because it requires 15 or 16 different factors when an antibiotic is chosen. So the flip side is that advanced decision support in human medicine, where they've tried to direct therapy based on using complex mathematical analysis has also been really difficult. It's a recognition of how difficult this field actually is. That's one. So there needs to be a hybrid approach to improve the quality of data going into these systems as well as using machine learning.
Exactly, and that's what I was going to say. Is I think that getting those systems into place is good, but I think that it should be adjoined with the other science that's there, which is let people use as natural of a language as possible, but then also maybe retrospective studies aren't as important as prospective studies. So I feel like doing these analyses and showing what the accuracy is, part of it should be looking at, what does it take to get them closer to 100% accurate? And then, just having the methods that you're talking about gets it closer and closer to 100% accurate. So if they do have some way that it's easy to put as in natural language as possible, or some standardized text, because there's a lot of research going around how to match natural text to a specific diagnosis code. So the closer we can get to being able to do that is one thing, but the algorithms are going to have the glass ceiling because you're only as good as the source data. So having the source data and then seeing what you can do with it is a big part of it. But then once they see like, oh, well, if we just write this, like what makes those, if you have one hospital that's 98 or 99% accurate with algorithms, what are they doing that makes them so accurate? And using that to inform what other hospitals should be doing is probably the best way to approach those issues, rather than just saying, we're going to come up with this thing, machine learning, natural language processing is great over here, and then we have another standard. Because I think the same thing on the flip side, just saying that AI is going to solve everything is not a good solution either. Because this was shown in, they do it with, they were looking at mammogram studies, and they're a really good study for how to implement AI solutions into the field of medicine. And in human medicine, there's a well-reported study that looks at, because they're able to detect early stages of breast cancer using algorithms better than doctors. Well, if you implement a system like that to the doctor directly, they don't necessarily like it. And so there's a lot of pushback and going back and forth until they finally have something that's the board approving it along with the computer scientists doing it, rather than it just being a one approach sort of fits all. It has to be, like any of these things where we're using like AI to solve our problems, there has to be a joint effort, I think, between the two fields to make it better. Oh, sorry.
Steve again. Naive question. With the antimicrobial dosage data you're generating, is it feasible to feed that into a pharmacokinetic model and form a view as to what extent practitioners are prescribing such that they stay out of that mutant selection window for time-dependent antimicrobials? Is that feasible?
So sorry, will you repeat the question one more time?
You gave the example of the amoxicillin.
Right.
50-kilo dog, 2 tablets twice a day. Is it possible to feed that data into a pharmacokinetic model to just determine whether practitioners are actually prescribing appropriate dosages to stay above the MIC, but also above the mutant selection window?
Yeah, no, absolutely. As long as we have, that's why we looked at the, the short answer is yes. So the question was, is there a way to plug in the data about dosage rates into a pharmacokinetic model to look at if there's a specific drug that requires twice daily dosing, to then look at if it is being effective or if they're giving the appropriate dosage? And the answer is yes. Like that's, as long as you just have a list of each of the drugs and what the minimum requirements are, then you can just feed it through an algorithm, and it could very easily be a decision support system to do something like that too. It would just be a matter of presenting the data at the right time in the right place to be useful to the person prescribing it.
Blaine, did you have right? Thank you, Brent.
Thank you.
Alrighty. 2 more questions here. All right. We might come back to your questions at the end of the second presentation. So thank you, Brian. Our next presenter is Jéssica Kayamori Lopes. She's a PhD fellow from the Catholic University of Paraná in Brazil. And her topic today is antimicrobial use in veterinary medicine in Brazil and the challenges for antimicrobial stewardship. So we'll just switch over to the next presenter. Jéssica, are you online?
Yes, I am. Can you hear me?
Yes, perfect. I can hear you.
Great.
And could you share your screen? It should take over this one.
Okay, there we go.
All right. Okay, just give me a second to test this.
Okay.
All right, perfect. We can all see your screen. Thanks, Jéssica. You can go ahead.
Thank you very much, Arjun. And also thanks for the opportunity. It's really good to be able to talk about a little bit how things have been rolling in Brazil. So good morning and apparently good evening, everyone. Just for you to understand a little bit on the background of how did I get here. So basically, my field of expertise is basically, I have been working as an international consultant with international organizations such as the FAO or WTO, working around thematics such as zoonosis, antimicrobial resistance and food safety, capacity building and multi-sector collaboration mechanisms in different regions. I basically managed to connect with NCAS through the Australia-American PhD Research Internship Program, which is basically a program provided by the Australian Academy of Science and funded by the Department of Education from the Australian government. And I'm actually based in Wagga Wagga, following up activities with Professor Jane Heller, and also working in collaboration with Dr. Monica Lara from New South Wales Self Pathology. And so just for you to have an idea, because I'm going to be doing some comparisons between Brazil and Australia, just for you to have an idea, Brazil is a really big country. So size-wise, it's pretty much similar to Australia, and I will show you a little bit more about it in the next map. But we basically have a total of 26 states, which you can basically see in the map. And basically, when it comes to size, so you can see Australia, that would be this bluish image that you have. And size-wise, we would be more or less like the same, but somehow Australian population would be way smaller than the Brazilian population. Comparing both of them, so political-wise, we would have more or less the same structure. So Brazil is also run by the federal government, and every state would have its own state government. We both have a really huge importance when it comes to agricultural activities and economics. So we would eventually have the same export markets and also similar domestic market consumption when it comes to crops and also animal protein or animal products. And right now, consumer behavior regarding antimicrobial resistance in Brazil, and from what I understood also here, is that there is still not that big pressure on animal production itself. So consumers wouldn't be raising that as a big issue. So yeah, just to touch base a little bit on this agriculture and livestock side. So huge crop production, a lot of importance on that. Animal production wise, we are high in the rankings for cattle production, pork production, and poultry in terms of exports, and considering the size of the market worldwide. And also many other varieties of animals, animal productions, and also a really huge growth and potential. And I would raise here aquaculture, just because the aquaculture and antimicrobial resistance for water, it's a really big thing, and it should be taken into consideration, even though sometimes I just have the feeling that we tend to consider aquaculture as a secondary issue, but just to bring it up and also consider aquaculture as an important point in terms of animal production and antimicrobial resistance. So basically, going back to the context, so we are aware about the global movement and how the tripartite alliance, FAO, WTO, and OIE have been raising awareness and trying to make member countries engage on antimicrobial resistance, and all this movement that started back in 2015 with all these high-level UN meetings. So the development of the national action plans, and well, Brazil as a member state also decided to start developing the national action plan. And last year, in 2018, 3 agencies came up with the Brazilian National Action Plan to control antimicrobial resistance, considering a One Health approach, which would be PAN-BR. And then you would have the Ministry of Health, the Ministry of Agriculture, and also the Anvisa, that would be the that Brazilian Health Regulatory Agency. So the 3 of them came together, and they were putting a lot of efforts to develop the National Action Plan, considering many different aspects. So just for you to have also an idea, so Anvisa is autarky that is linked to the Ministry of Health, and it's also coordinating the Brazilian health regulatory system, and they are basically responsible for sanitary control in terms of production, marketing, use of products and services that are actually under any health regulation. The Ministry of Agriculture, that will be MAPA. You will see that acronym quite a few more times during the presentation. So they operate in a special program for antimicrobial resistance, and they are also coordinating, all the activities in the National Action Plan. Each of the agencies also have a specific plan of activities under the major National Action Plan that is PAN-BR. So discussing a little bit, entering a little bit into the human health aspect of that. So since 2010, we do have, Anvisa has actually established a system that is the SNGPC, which would be the National Management System for Controlled Products. And this will be actually linked straight to the pharmacies. And basically, that's where if a person needs to buy an antibiotic, this person would go to the pharmacy, and then you will have like your prescription. They will collect all the details of the prescription, retain one version of the prescription, and they will add these inputs in the system. And since 2010, this is compulsory. So everybody that needs actually to buy antibiotics for human consumption, they would actually have this data collected. In terms of antimicrobial AMR surveillance, so last year they started a pilot called BR Glass. So Paraná state was actually the first state to join GLAS, representing Brazil somehow as a pilot, and that would be all coordinated through the Central Laboratory for Public Health, which will be LACEN, and this would be the National Public Health Laboratory Network, and you would have different laboratories in different states. But as a first step, so the Paraná state is the one that is actually engaging on GLAS, and we have been providing data to the GLAS system, so the Global AMR Surveillance System coordinated by WHO since last year. And surveillance-wise, Brazil is also part of the Latin American Network for AMR Surveillance, which is called RELAVRA, and is actually coordinated by the Pan American Health Organization and WHO. So it's a total of 19 countries in Latin America that have been providing data on nosocomial and community microbes. And also, we are part of the RILA or INFAL, Spanish for RILA and INFAL for Inter-American Network of Food Analysis Labs. This is actually coordinated by PANAFTOSA, so it's the Pan American Center for Foot and Mouth Disease, but they have been working around a lot of different thematics that are related to veterinary public health. And this have been really great opportunities to exchange a lot of knowledge and to understand what is actually going on in the region. You will know that you actually have, I started in after the SNGPC, and this would be because when it comes to SNGPC and prescriptions in terms of animal health, we do actually have in the system sometimes some veterinarians that would actually recommend the patients to go and buy antibiotics in the human pharmacy if it's actually not available in the animal health pharmacy. So basically they would be going and providing the prescription, and then in the system you would have an option to point if it is a veterinary prescription or human health prescription, so it would differ in the use. In terms of feed production, so medicated feed production or use of antibiotics as feed additives, so there is a compulsory and a legislation supporting that is actually like necessary, and I will be able to go through that in a couple of slides. And but when it comes to treatment, there's actually no control of veterinary prescriptions, in a sense that you can buy antibiotics for animal health purposes without having a prescription, and that could be from different sources. You could find a vet pharmacy, and in specific vet pharmacies, they would only be available in really big cities, such as the capitals. But when you go to the countryside, you will eventually find pet shops or agro shops. And when I say agro shop, I mean shops that are actually selling different kind of things, such as farm materials, feed to different animal species. They would have a small pharmacy inside where you can actually buy drugs. And even some clothes or anyways. So it's a really huge variety of products that you can actually find in agro shops. Yes, so there is no actually real, a huge control of prescriptions in animal health when it comes to treatments. And most of the times when you go to these agro shops, I can enter in further details later, but it's basically, it will be an over-the-counter kind of sale. So the person that is actually selling would just recommend any kind of drug or any kind of product that actually would be suitable for the client situation. In terms of surveillance, we do not have a system. Brazil is still not doing any kind of surveillance, or the government still not established something. What we have now is AgroPrevine, that is actually a program linked to the National Action Plan of the agricultural side, trying to do some promotion of prudent antimicrobial use and trying to coordinate activities related to the National Action Plan. But yeah, also data on antimicrobial use is not available in the country because so far we still didn't manage to start collecting them, which link us to the project that I'm working on that I will talk about a little bit later too. So some recent actions from the Ministry of Agriculture. So basically they had this call last year to the private sector. When I mean private sector is the pharmaceutical industry, so they could report information on antimicrobial sales. Last report that was actually published was in 2015, and they started to request this information to input on the system, call it SCIA, and they basically were requesting information from 2016 on. Last month, I think it was in July, there was they were circulating some emails in order to collect information on ongoing projects related to antimicrobial usage, and that was in July. So they basically recently collected this information, but so far we're still not aware of what is going to come up from that. And really good news that last week on Friday they have held actually this workshop, and they published that information on their website, which was a workshop regarding prevention and control of antimicrobial resistance in animal health, and they would be highlighting better supervision or how to move forward with AMU, how they can actually also move forward with public awareness in terms of marketing and pubs, how they are going to reach the targets, and a lot of discussion about extra label use of antimicrobials. And they would have participants from Anvisa, from the Federal Veterinary Council, pharmaceutical and feed industries, agro industries, and some farmers and breeders association. But that was really recent, and unfortunately there are not further information regarding it apart from what they actually have published. So yeah, so just touching a little bit on feed prescription. So in Brazil, there is this legislation, which is this one highlighted in the box, so Instrução Normativa number 65. And this is basically legislation that actually actually inform. So the veterinarian would prescribe a medicated feed to the farmer, and basically it's standard form, so a standard prescription form where you can actually have to add a lot of information, and this is standardized because this prescription, so the feed mill needs to send that request to the Ministry of Agriculture, so the Ministry of Agriculture can analyze and approve the production of this medicated feed, in a sense that they would consider if there is any other kind of active principle that is actually in this prescription that wouldn't match with whatever they put as a reason. Well, the Ministry of Agriculture would have 3 days to come back to the feed mill and say, yes, you can do it, no, you can't do it because of this and that. Usually it will be a single treatment, and it should be used in maximum 30 days. And after this 30 days, they should the farmers should then dispose that appropriately. Sometimes we can also consider that this feed mill, so in Brazil, we have a lot of cooperatives that would be engaging in animal production, and each of the cooperative would also have their own feed mills inside. But then the cooperatives also have veterinarians that are actually working in the same enterprise, if we can call them, like, to see them as an enterprise. So yeah, this is a little bit, sometimes you can see a little bit of conflicts of interest. And also, well, you also have the private sector with their own feed mills plans that will be also getting requirements, prescriptions to approve production for medicated feed. And well, antimicrobial stewardship. So that's a really interesting discussion because stewardship, it's a word that has no translation in another language. So when you mention stewardship in Brazil, or even in other countries where they actually don't have this word, so non-English speaking countries, we usually go for a phrasing and trying to explain what everything that is stewardship means and all the actions that should be taken and whatever should be considering under stewardship. But in Brazil, one way that that the government actually managed to translate that, so they would be using wording such as management or monitoring, and also always explaining. And in terms of antimicrobial stewardship in human health, so there is Anvisa guidelines that were published in 2017. So it actually would support hospitals or other IPC programs and healthcare units on how to actually develop an antimicrobial stewardship program within their units. So there is actually this BRASA, which is Brazil Stewardship for Antimicrobials, which is basically provided and supported by the Brazilian Institute of Patient Safety. And you will find, I mean, I wouldn't be able to go through a lot of details about it, but healthcare units, hospitals, and they have been entering this kind of programs and developing standards in their own facilities. And there's also a Brazilian Commission for Health Infections, and they would also be coordinating a lot of that. When it comes to animal health, so we still not have guidelines to any animal species, and that means that even animal hospitals or clinics, they wouldn't have a protocol to follow. They wouldn't have guidelines. We wouldn't have any association, so any animal health association to pets or providing this kind of guidance yet. In terms of feed additive use, there is a list of banned antibiotics. We come up to 10 prohibited antibiotics to be added in medicated feed. And also the Ministry of Agriculture they have a prudent use webpage where you can actually access all this information related to the use feed additives legislations, and also some content from OIE and some other information about prudent use regarding antimicrobials. And when it comes to, so where's the challenge? So basically that is a big challenge for us. So we can actually start developing these guidelines and getting people to engage in such a, I could say a recent thematic, if I put that in brackets, because antimicrobial resistance is still a really recent something to many different areas, and the general population in Brazil too. So that's the challenge itself, is to start taking actions to try to address the situation. And okay, so going to my project. So I'm under the supervision of Professor Claudia Pimpão and the co-supervision of Dr. Javier Bouchat. And my project will be an informational system to control the use, commerce, and prescription of antimicrobials for veterinary use in the state of Paraná, Brazil. So this is Paraná, the blue state that is highlighted there. So it's southern region of Brazil. And it turns out that it's the biggest fruit producer in Brazil in terms of exports and also production. It's highly ranked as first for, animal production and crops production and dairy. So there are a lot of cooperatives around for poultry, for the pork industry, for dairy also. And so it's really important to the country as a whole. And following what the PAN-BR Agro, so that's the Ministry of Agriculture specific plan in terms of animal health. So the idea was to basically understand how veterinarians that are aware about antimicrobial resistance and One Health. So that would be the first phase of the project. And then as a second phase, and here I need to bring up our regional state. So ADAPAR would be the Agro Defense Agency of Paraná, which would be the state government responsible for agricultural activities. And so they are a big partner on that, because basically what we are doing is we are analyzing and trying to quantify antimicrobial use through sales data. And how we are doing it, the idea is to consider that, so Paraná is one state that actually has a legislation that actually demands all agro shops that needs to be registered to provide reports every month in terms of antimicrobial sales movements and stock. And that would be where we could actually collect this data and analyze this data, knowing that they have this legislation in place since 2015, and until now, they have never analyzed anything that actually came up. So since 2015, there is available data that was never analyzed, and basically that's what we are trying to do here. And then after second phase, the third phase would be to develop a methodology and try a pilot system of an informational system that could actually support ADAPAR in moving forward with that, and even given a little bit of upgrade in their actual legislation. So we are also working with the Regional Council of Veterinary Medicine, so that will be in Paraná, and that will be where we will actually be collecting information from veterinarians. So all registered veterinarians that are actually linked to the Regional Council would be getting these questionnaires, and some technical support from Pontifícia. And where we at in the project, so basically on the first phase, we are actually doing the data analysis and the statistics, so we can actually come up with results, and hopefully that will be done by November. Basically the idea is to get active vets to reply to this questionnaire, and we consider that all registered vets from the regional veterinary councils will be actually active as a professional. And phase two, so basically we got reports from ADAPAR on a 6 months timeline. So we consider from November 2018 backwards, and we got the reports from a specific region to analyze. And then all this data was tabulated, and that was a lot of efforts from the team, because basically the reports will be coming in a lot of different presentations, so PDF, paper, handwritten, sometimes even in an Excel table, really inconsistent. And right now, data analysis and statistics are being done, and the idea is to define milligrams of antibiotic per region, considering the active principle of each of them, and 10 try to estimate that the use based on the animal population that we have there. Yeah, so these two phases, they will be they are to be completed by November. Then we can actually start engaging on phase 3. And just to touch base a little bit on Charles Sturt University activities, so under the supervision of Dr. Jane Heller, there are ongoing projects regarding AMS and AMR in animal health. So we have Kelly Thomas, which is a PhD student actually investigating selection pressures in the Riverina region using a One Health approach. So that would be, she would be considering prescribers to be taken into consideration to respond a questionnaire, and then trying to do some geospatial modeling, considering hotspots of water sources and some wildlife, but even considering invertebrate wildlife, so such as flies and also different kinds of animals that would be in these hotspots. And then after that, do a risk analysis of in the animal-human interface to understand what are the risks and what is actually going on in the Riverina region. And this AMS and marketing related to the Veterinary Antimicrobial Stewardship program being carried by one of the honor students. So we're trying to develop a bottom-up approach to engage veterinarians on antimicrobial stewardship and see how is best to engage them. Yes, so that's basically a few of the things that we're following up here, and I'm actually following up here in Australia. And I think that's it. Happy to take any questions or to clarify any points that I may have just passed a little bit. So yeah, thank you.
Thank you, Jéssica. We have some time for questions. I don't see people. Would anyone like to?
I'm trying to find the questions or found it, sorry.
Jéssica, I'm going to stop your screen. That's okay. Oh, okay, perfect. We had a few questions from some. Yeah, we had a few questions online. Might be tricky to retrieve those questions because the screen isn't opening up. But if anyone here would like to add anything. Jéssica, I was just wondering, what are the commercial factors that might impact on the establishment of a surveillance system in your state?
I'm sorry, can you repeat? It's really low.
Oh, okay. What are the commercial factors that might influence the establishment of a surveillance system in your state?
What are the?
Commercial factors?
Okay, commercial factors?
Yes.
No, I'm sorry, Arjun, I can't hear properly. That's why. I don't know if you're far from the microphone.
Oh, no, I'm close to the microphone. That's interesting. Yeah, so commercial factors.
Commercial factors that can actually influence?
Yep. Yep.
Okay. So I don't know. So in terms of commercial factors, so if you consider that we have, one point that I actually forgot to mention is that to compare how we can actually dispense antibiotics or antimicrobials in Brazil compared to Australia. So basically here, I understand that like veterinarians are the one that are actually dispensing antibiotics. And once you go back to Brazil, you can actually have a lot of, I wouldn't say informal ways of dispensing, but a lot of different ways that you can actually access these antibiotics. So I don't know if that's the commercial factors that are like have in mind, but rather you can go to vet pharmacy, which would be really correct, or you can actually have pet shops or agro shops that would have this tiny little pharmacy where you can actually have access to antibiotics. And also, like once you are in a pet shop, which is linked to an animal clinic, well, you will also have like the veterinarians from the clinic that will say, oh yeah, so you need this product, and then, but you can get it like in the pet shop nearby, or usually it's actually the clinic is inside a pet shop or something like that. So, well, that's another kind of, you make this indication. So yeah, you can buy it from here. Agro shops, over the counter. Basically, a lot of people would get there by just simply saying, so, oh, my dog or my cow has this problem, what could I use? And that the person would just choose, the person that is in the other side of the counter, by that said, would just choose something or would sell something that this person thinks is actually useful for this kind of situation. And you also have commercial technicians from, well, the private sector, from different pharmaceutical enterprises or different areas that we can actually go to the farm and say, make, you know, the pub or talk about a different product and say, oh yeah, so I think that it would be really useful for your farm. So if you want to buy some, and then that would be the technical, the commercial technician that actually can reach out to farms doing their, you know, routine visits and eventually sell, you know, antibiotics too, without it actually, you don't need to be a vet to be on the commercial side of an enterprise. So basically these commercial technicians could actually just sell antibiotics, and then this information would be related to the private sector. So they would have this information, but we wouldn't know how many of them do that and how many of the farmers are actually buying directly from them. Let me think if I have any other. Well, yeah, big cooperatives also, they would buy straight from the private sector, so straight from the pharmaceutical industry. So that's another kind of information that is really difficult for us to get. So what cooperatives have been using and how much they have been using. So commercial-wise, they just deal it straight with the private sector. And yeah, that's all I can think about.
Jéssica, that was very interesting and informative. You both, Brian and Jéssica, we might end the seminar today here. Thank you all for attending. There are a few comments online saying that some of the attendees would like to contact the presenters about their own work and to thank them for your presentation. So thanks very much and see you at the next meeting.
Thank you.